I'll probably make some comment about my experience. I'm not programming since a long time. These are my pet projects, Desert and the Perforator plugins, and these are vibe-coded projects. So it will be my vibe coding experience in trying to build the plugins that would help developers. Yeah, so it's the first one is a Desert, and I think I released it 5 to 6 months ago. And I will just probably describe how it works, what was the concept or idea behind it first, and then I share my experience, issues I faced, and the lessons I learned on the way on releasing this plugin. So that was my first one. And I will probably start from how we write unit tests, how developers write unit tests. And usually it consists of 3 parts. The arrange part, where we describe our dependencies, where we say, okay, we have these input values, which we are going to use in our test. We will do something with these values, and these objects we mock, let's say. So in the second part, in the act part, we just describe what we're exactly doing with this values. Yeah, if we have a calculator and we want to add 2 to 3, then we do the calculator add, let's say. And the last part is assert part, where we check if our actual result is matching the expected result. That's like basics of writing the unit test. And the question is, when we are using the LLMs, the LLMs really has issues of knowing what values to use and what are the dependencies. And sometimes it's just the place where we have a lot of hallucinations and we need to retry and correct just to have a good unit test. So the question is, yeah, if the values, input values and the output values are not in the code base, so where we're gonna take them, yeah? So what will be our source? And the question is it a good way to predict them? Or maybe there is an option to retrieve them from somewhere. So prediction means, yeah, it could be inaccurate because we're just predicting it based on our code base. So if we say it's calculator, okay, it's an easy example, but if it's something more complex, then it could be something tricky, yeah. And then you will just have more iterations to generate your unit test. So what about the retrieval, where we can retrieve this information? And I would say there are 2 sources or where we can get this information. The first source is human. Yeah, so we as developers, we know that we need 2 and 3 and we will get 5. So that's pretty clear. Another source of this information is our runtime of the application. So we can retrieve this information from our debugger, which has all like the call stack. We see how we ended up here in this part of the code, which input values were used, and what are the output values. So it could be an option for us to use a debugger, which is already present in the IDE and contains this information, and use it for the LLMs. So yeah, as you can see here, when you're asking yourself, what should I mock, or LLM is asking itself probably, what should I mock, you can provide this information. So this was your call stack. So you ended up in this method, and previously you called this method with this values. So it could be useful as a context for the unit test generation. And yeah, so the same for the input and output values. So the debugger has answers for this. And I just wanted to have a big picture of how I wanted to build it and what could be useful as a context for the unit test generation. So yes, we have our debugger, as we discussed. We have all our values and dependencies there. We have our build configuration, so we can see which libraries we are using. It could be also very useful when we generate the test. So we are not using some frameworks or libraries which are not used in our project. So we can use the Gradle file to as a context. And our code base, so it's also a good context, which helps LLM to understand what are the dependencies and what sections of the code I should use to create this unit test. So our task is to get all this data, all this context, and maybe make one prompt that that would contain all the necessary parts, which would narrow down the hallucination of the LLM, and use an LLM model. So in my case, use the Gemini. It also supports OpenAI and Anthropic model, and then let the model generate the file with test, or update the existing file with some new unit test. And the concept, the idea here is very simple. So it's called dessert because it's debugging and asserting. So it describes the workflow, I think, pretty clear. So that was an idea to call it the dessert. And here is a short demonstration on how it works. I took the sample application from the Kotlin multi-platform. It's gallery where you can apply different filters, and you will see how I use it. I use the plugin to generate tests for this application. So yeah, I put the breakpoint and start debugging. So I want to debug applying the grayscale filter. So I'm running the app in the debug mode, and the debugger stops on this line, and now I can generate tests from the values. And it takes some time for Gemini to respond, of course. And then you have your file, which exactly tests what is supposed to test. Yeah. So if it's a grayscale image at the end. So it's pretty easy, and it's Kotlin multi-platform compatible, so you can also use it for different platforms. I think it's pretty handy. So, and the plugin is available now. So as I said, I released this 5 or 6 months ago. It's available in your IDE, and you can also download it from the website. It's an open source project, so everyone could contribute. And it's MIT license, so you can do whatever you want. And you can see here on the screenshots how it works in the basic. Yeah, so you have your IDE where you can right-click and generate the test. So the only thing you need is just to run this in a debugging mode, which means you need to configure your debugger. So the problem, the technical challenge for me was, even though it's a web-coded project, you need to understand how it would generally work to write the prompt. And the first thing was to understand how I can access the runtime data, so how I can access the debugger. And the IntelliJ platform SDK has this a part, the framework or library, common IntelliJ X debugger. It's an abstraction layer that allows plugin developers to interact with debugging sessions. And basically, it has different layers which you can use to access this data. So first is a Xdebugger manager, which contains different debugging sessions, as far as I understand. And you can, through this manager, you can access your Xdebug session, which is current session you use in your debugger. And then the next step is you have an access to your stack frame, and you can see your call stack, and then you can compute children, which means populate the values from the current debugging session into the values. So then you can use it as a context for the prompt. So you can take the real values from the methods you use. You can take the call stack and use it as a text in the prompt that you send to your LLM. And yeah, so there are issues, of course, while web coding the plugin. So of course, it's hallucinating APIs that don't exist, generic answers, not specific to used versions. So you start building the project, it fails all the time because something just wrong. Yeah, so it's completely random sometimes, and you need to iterate over and over just to make things work. And I try to do some basic things first, and then on top of this build some additional functionality. So I have some working state I can roll back and try again. And the third thing is missing clear documentation for the Xdebugger usage. So I found the GitHub project where I looked how it works, just to understand for myself, to validate the output of the model I used. But still, it's a source. It's not just a demos, or it's not that easy for a beginner to start with. So that was my my difficulties I faced. And the lesson I learned that it would be great to have the documentation as a context for the LLM to generate the plugin. If you know, or some other developers know, there is a Context7 MCP server, which is basically the database of documentation for different libraries, frameworks, including IntelliJ IDEA Community Edition, which contains this Xdebugger API, which I used, but I didn't use it back then. So that was my issue, that I used ChatGPT. It was even version 4 back then, I think, and it was hallucinating a lot. But if you want to reduce the number of hallucinations and reduce the budget you spend on creating the IntelliJ IDEA IDE plugin, I would highly recommend to use the Context7. I think it's free, as far as I remember. It's vector search behind it, so it means that it will find semantically closer pieces of the API, and it will just use it as a context for generating the new code for your IDE. Yeah, so that's the lesson learned for me. And other lessons, I think it's general for the software development right now and vibe coding, is how to reduce the number of, like, the amount of hallucination, and how to build more accurate and more specific software. So, and what could be what could be a source of the context in general apart from our code base? Yeah, because yes, we build software currently based on what we already have in our code base, but there are a lot of other sources which would be very useful. Same as for human developer, but also for the LLM. So first, of course, it's a source, yeah, as I said, and here the different approaches. Cloud Code, as far as I know from reverse engineered documents, it's using the grep and ls just to navigate through your code base and find the relevant pieces, which it includes into the prompt. Maybe, I'm not sure about the Juni. Maybe Juni use PSI, the program structure interface, which is basically a tree to traverse and find the relevant pieces of your code. It could be also a good way of finding the relevant parts. Yes, I'm not sure what currently exists, what navigates and index the code. Maybe there is some semantic search solution, but it's quite challenging right now at the moment, as far as I know. Yeah, what else could be useful is data. So the MCP server that can access your test database and retrieve some values. So for example, if you're generating integration tests, that could be very useful to find some test values, like test products or test users. So that would be also relevant when you build some logic that is based on the current structure of your database. So everything which is related to the database, including your schemas, or including the direct connection to your database and retrieval data from there, that could be also useful. 3, infrastructure. Infrastructure is good if you have like Terraform there, or you have something else that represents your infrastructure. For example, you know your Redis version, and you know that this API would work in this Redis version. This could be also valuable information for LLM, so it's not hallucinating too much and giving you something that wouldn't work in your case. Yeah? So it's taking versioning into consideration. 4th is a documentation as a code. Yeah, it makes sense to keep it in the code base and as a context for the new code generation, to give to narrow down again and giving a little bit more insights for the LLM model, how it works without getting deeper into the methods and the code lines. And as I mentioned, Context 7 is a great addition to that if you are dependent on some other libraries and frameworks or programming languages. So Context 7 contains the up-to-date documentation and can also help you to reduce the budget on generating your code. And the fifth is where I tried to focus, is to use the runtime information, which includes a debugger, which I use in a dessert plugin, which takes the runtime data. I know that the cursor is also looking into the debugger to get the runtime data to identify the memory leaks and so on. So that could be also helpful when you're trying to generate or refactor the code and make it more performant. Also, observability tools is a great source of context for the LLM because like what you see locally with your profiler is not the same as you see in production. You have way more use cases. You see what works slow, what affects conversion, and where you have the bottlenecks. Basically, because you have a bigger database in comparison to your local database. Usually, yeah. So it doesn't mean that it's always like this, but usually it is like this. And that could be very useful to get these bottlenecks and the flame graphs and to use it to refactor your code. Also, BI tools, which is potentially could be also helpful and to retrieve the information about what the customer journeys are, what the places which are most critical for the conversion and so on. So that could be also very useful. And talking about observability, that's a topic I wanted to start with while talking about my second plugin, which I released about a month ago, which is called Perforator. And yes, as I said, this is a Grafana Pyroscope, by the way. It's a continuous profiling tool, same as New Relic or maybe Datadog or Instano. If you use something of that, I think that's a great help for every developer because you see how your software behaves in real life and where you have the bottlenecks. So you can use the flame graph view and to identify these bottlenecks. And here is just an example. This is a screen I took from their GitHub repository. So yeah, you can see that there is an example of the application where you can order car or bike or scooter ride, and you can see in this application that we have a car service order car method, which takes most of the time. So this is a place where you want to focus and to improve your performance. And the question is, would it be helpful for developers to see this continuous profiling information in the IDE? And I think, yes, it is. It is useful. So it's more visual for you how your code affects the customer experience and where you want to focus your efforts to optimize. Also, would be great to have this information to refactor it with the AI agents. So yes, talking about the plugin, it's called Perforator because of performance, and it was just the name I wanted to use. And this is the workflow, how it works. So I took this Java application, sample Java application, which where you can book the ride, and it collects the Java flight recorder profiling data and exports this data in a Pyroscope, which I think stores it in a pprof format. And with the perforator, I retrieve this data over API in pprof, and then I render it in the IDE itself, in the IntelliJ IDEA. And I show this labels with a red or silver, showing this is the places where it takes most of the time, and these are places where it's okay. I also added integration for Google Cloud Profiler. It's the same concept as a Grafana Pyroscope. The only difference is that Google Cloud Profiler provides API, but it seems like it doesn't work in terms of retrieving the CPU data and memory data. So it gives some general information, but I wasn't able to extract this data, the performance data from there. So I built a smaller version where you can download the profiling information and upload this in the IDE. So Periscope, the perforator is using API to connect to the Periscope and retrieve the data, and it's using the file from the Google Cloud Profiler. So you need to go there, download the file, and upload it into the perforator. So yeah, unfortunately, that's not working with the API for Google, but hopefully they fix it, or maybe I find the way how to make it work, and then I can also edit. So it's very simple to use. It's in the tools, you just fetch profiling data. Previously, you need to configure in the backend settings your API endpoints, your credentials, and what type of data you would like to retrieve and what will be the time span. But when it's configured, you just fetch profiling data. It will collect all the data for your application for a specific period of time. And then you will be able to see the bottlenecks on this left side from your source code. It's similar to the profiler, which is built into the ultimate version into IDEA, but I had to build it from scratch because it's not part of the community, and just wanted to have this plugin available for everyone. And at the final, you can adjust settings, so you can choose if it's CPU or memory. So you can find how much memory is allocated for specific method, or you can change it to CPU and see what the time used for the specific method and all the methods which are used in this method. And then you can also switch to the CPU time, to the wall clock time in the Google Cloud Profiler. There is some difference, but I will not get deep into this. So yeah, you can define the threshold and you can define the time. So you can say, okay, I need the information, providing information for the last 1 hour, 3 hours, 1 week. And this is my threshold. So I want to IDE to show me all the methods which are above, let's say, 50 milliseconds. Yeah, so that's how it works. And this is the demo. This is the application I used. It's also taken from the GitHub repository of the Grafana Periscope. It's basically simulating the ride booking application that works in different regions and collect the profiling data from different regions into Periscope server. And my plugin is connecting to the server and retrieves the data and shows all these labels in the IDE. So here is a short video. I think I start with fetch profiling data, and it's the Periscope, so you can see, and you can right click on the badge, copy the prompt, and use Journey to refactor this piece of code. And Journey connects to the Periscope through the MCP server, so it collects also all the relevant information which is specific to this method. So it's not just taking the information, hey, make this method more performant, but it also takes information, if necessary, from the relevant method and its performance. So I think it's quite useful way and quite efficient way of doing the performance optimization. Yeah, so in case, let's say you have an application and you have an SLO, and you see that you are over your year budget for this month, and you want to invest more time into the performance optimization, make your website respond in a faster time. So you just do this, and it would save you a lot of time, I believe, and I hope. So yeah, another use case is Cloud Code in IntelliJ IDEA. So it's a Google Cloud Profiler. You download it from the Google Cloud Profiler, and you upload the data. So you just upload the file here. It will parse it from the PPRO format, and also will render the badges. So you can just right-click, paste the same workflow, paste the prompt, submit the prompt and let Cloud Code do the stuff for you. So I think here it just suggests improvements. Or you can, in my preferred way, to use Juni. Same approach, copy, apply threshold, paste here, and Juni will just do all the work for you. Will suggest the refactoring. So it's also very, very useful, I would say. Also available right now, as I said, 1 month ago, I released it. I don't have many downloads, but maybe after this event, it will be more. So I hope so. And the cool thing is, it was, so the developer of the Pyroscope, the Grafana Pyroscope, the Rampare, he saw this plugin and he said, "Oh, that's cool. I want to make my own for VS Code," and he released his own for VS Code as being inspired by this plugin. So I'm very proud that my second plugin was already had some influence, and that for me it's a pleasure that it happens. Yes. The issues I faced, as I mentioned, I wanted to reuse the performance badges into of the profiler, which is built into the IntelliJ IDEA Ultimate, but I didn't find how I can do this. I think they are not part of the community source, so probably that's correct that I wasn't able to do them, to implement them. So I was able to make them from scratch. And that was, I think, the trickiest part of all the vibe coding part. Yeah, so I think it's well better done as in comparison to my badges, because you can see a lot of valuable information, and my version was very simple, but I wanted to start simple. And so making own Guto badges wasn't that easy. So I had to create my own renderer for the icon and use graphics 2D library to draw these badges. And the second step was to implement the annotator, which is waiting. It has a dumper, which means that it's waiting for the indexer to finish indexing the project, so it can identify and map the methods which I take from the flame graph to the methods I have in the project, so I can understand. So the plugin can understand where to render these badges next to which methods. And third was to override the annotate method, which decides which lines needs badges. And yeah, you have the range highlighter where you add this this renderer to. So that was the final step of the logic that renders this. So I think if someone is interested, can have a look into the source code. It's not the best, as I said, it's vibe coded. So I just wanted to make it work until I focus or spend time on making it really nice and easy for other developers to contribute. But if you're interested right now how it works, you can have a look. And if you have some ideas for your plugins which you want to add some information next to the code, it would be also maybe helpful for you, because there is not much documentation online which you can use to implement something like this. And probably some thoughts I would like to share. The role of IDE, and for me personally, it feels like it's getting more a context manager for the code generation. Yeah, so I was talking about the different sources of the context, not just the code base, but also all the ecosystem, documentation, infrastructure, database, maybe something else, runtime, which I use, and I see that other people go into this direction. So that's probably the next role of IDE, if it's not already a role of IDE, to manage this context and to get all this information, which I think in most of the cases is bigger than the context window, and try to summarize it and put it together in a way that it reduces the budget for the code generation, make it more accurate, and saves time. And while I was developing my plugin, the second plugin, the perforator, I faced the issue that, yes, I want to use the AI agents like Juni or Cloud Code, but I'm not able to send my prompts and trigger the process. So I think it would be very useful. And I think that could be also an addition to my first plugin, to Desert, to let the AI agent to change the code according to the context I give. Maybe I didn't find the way how to do this, but I checked if there are any actions which I can use from the Juni plugin or Cloud Code plugin, and I didn't find it. So that would be a better way, because currently I implement the copy and paste. So I copy the prompt and paste this into the Juni or Cloud Code and let it and submit this prompt. So it would be great if I can do this automatic. That would be my way smoother approach, in my opinion. So I took an action and created tickets to make it happen. So I created a ticket for Juni in the U track, and everyone who is with me and want to have a possibility to send prompts from your plugin to Juni to let Juni do something for you. You can go to this to uTrack and vote for this, and maybe add your comments that would be very helpful for you too. Or if you're developing for Cloud Code, it's also an option. You can go to the Anthropic GitHub repository, and for the ticket 7005, you can also vote and add your comment there. It would be very appreciated if you could do this, and then if you think that would be valuable for you too, of course. So please vote. Yes, so these projects are open source. They are on GitHub. Everyone who wants can just join and do whatever you want with this. And they are under MIT license. So yeah, and this my first two plugins. So please don't be too picky about this. So, and of course, everyone who wants to contribute are very, very welcome. Yeah. So I would say that's it from my side. If you have any questions, I would be glad to answer.
Thank you very much. So we need to hurry up because I have a million questions and I want at least ask one or two. So you were asking about Juni and how it feeds, basically, or how it gets the context. So we have several things. So until a few weeks ago, that's my up-to-date version, right? Juni was able to read files and get parts of it and include it in the context, but it did not use the PSI to traverse the thing. And I think what you mentioned, we have basically two use cases also for your plugin. So first, we have code where you want to create a test from, and you probably want to discover where functions are defined that are used within your stack frame, right? So that's where you would use the PSI for. But also you have probably the thing of discoverability, where you say, okay, I need to find a function that does something like that, right? And that's where a vector store comes in, and you can compare the vectors. So my question is, and that's a problem in general, we need to include all the information in the context and send everything over. So this is probably the whole stack trace, right? A lot of context values like your variables, and then an unknown amount of code that we need to give basically the LLM to make good decisions, what code to create and what to look at, right? So did you ever think about or run into problems basically where the context is just so big that your tokens explode?
Yeah. In my case, I had just some limits on how many, like what the amount of the data I sent. So the number of the call stack methods which I used. So of course it's I think in some cases it could be fragile, to be honest with you, because it's a first plugin I created, so I wasn't that didn't try to make it perfect. But in a test I made, it was enough to not to explode and not to break the the functionality. So I was even using the Flex version of the Gemini, which was free to use. And that was sufficient enough to provide some input values, the output value, and few methods which were called in a call stack.
Yeah.
But yes, you're right. I mean, again, it's the same point that I was talking about, how to fit all that stuff, all this context into the limited context window. And I know that Google goes in the direction of having big context windows in comparison to other models. But I think at the end, it will be still smaller than everything you can put into. And regarding the vector search, I was wondering if it already exists or somebody's actively working on it. And I thought, okay, that's a very challenging problem, because if you want to, let's say, build embeddings for a method which is less than 4 kilobytes, and you use 1,000 embeddings, you have 4 bytes coordinate, then you have 4 kilobytes for less than 1 kilobyte of code, then it will be a higher ratio of space you're using for the vector search. So I was wondering if there is a good solution, which currently JetBrains is working on, that would allow developers to use the vector search and semantically find the relevant pieces of the code.
Yeah. So I can assure you we have something in the oven that I'm probably not allowed to talk about, so I won't do that. But we are aware of the problems, right? And as you can imagine, if you develop plugins, right, you have to base it. So, and if you want AI help in plugin writing, then you have the whole platform code that you probably need to give access to, and then, right, you have, I don't know, 15 million lines of code or 10 million lines of code, right? So we are working on that, and that needs to be solved, and not only for us, for basically everything, right?
Yeah.
Because as soon as you're not working on a medium-sized project where you can pick the information, you're basically really bounded by the context.
Yeah, I'm looking forward. I think that could be very, very helpful.
Yeah. All right, Michael. Thank you very much for your talk. Glad to have you here.
You're well welcome. Thank you.
Come back. Come back again. Yeah.
Thanks for having me.